talk is going to be Calvin. I think many of you here probably use Segment. I don't think anyone's kind of touched as many APIs as Calvin has, and he's made them all completely usable for us. So without further ado, here's Calvin.
Boom. Hi, everyone. I'd like to start off by saying that today is actually my 10,000th day on Earth, and I'm excited to share it with all of you. Before we begin, I want to do a quick poll of the audience. How many of you out there interact with APIs on a daily basis? A show of hands? Cool. And keeping your hands raised, how many of you build and design APIs that are used on a daily basis? Wow. So still a pretty good number. Well, today I'd like to talk about a concept that I've been thinking about recently, which I'm terming building the Goldilocks API. Now, for those of you who may need a quick refresher, Goldilocks is this children's story about this little girl who's walking through the forest, and she comes upon a cottage. Now, in the cottage, she just brazenly opens the door, walks right in, and she sees 3 different chairs. The first chair is too big, the second chair is too small, but the third chair is just right. She sits at the chairs and then sees 3 bowls of porridge on the table. The first bowl is too hot, the second bowl is too cold, but the third bowl is just right, so she eats the porridge. And then she sees 3 beds. The first bed is too firm, the second bed is too soft, but the third bed is just right. So she falls asleep in the bed. And then, depending on which version of the story you're reading, basically the bears come back to the cottage, and either Goldilocks runs away and jumps out the window, or the bears eat Goldilocks. Now, I'm not really sure what sort of moral or lesson to take away from this story, if you're a kid. But on the other hand, one thing I do know is that we've spent years at Segment agonizing over how we build this API that feels just right. In particular, during this talk, I'd like to explore some of the ideas that we've encountered kind of building those APIs. In particular, start off by defining what exactly our API is, what our trade-offs are, and how we might mitigate them. And then finally wrap up with a few new ideas that we're seeing in the wild. So first up, defining our API. Now, API itself, though it stands for Application Programming Interface, actually gets thrown around as kind of a loose term. And if you're like me, you'd asked me a couple of years ago, I probably would have told you APIs are how computer systems communicate, you know? As an example, let's take the Google Maps API or the Google Location API. I can basically feed in some inputs related to my lat long, places I'm searching for, maybe an API key, and it'll pass me back a list of the taco places in San Francisco. And on the face of it, that sounds fairly simple, right? You request some sort of input, and you get back some sort of output. It's almost the same as a programming language. But what's going on under the hood is not really simple at all. There's all sorts of network hops that happen, jump between different levels of the networking stack, intermediate protocols. There's possibly several packets that are being sent and then parsed to get your request and response actually going through. And now what started as something fairly simple is actually a lot more complex. It made me think, API isn't even really the right word for this. APIs are not how computer systems communicate. That's really a protocol. So if protocols are how computer systems communicate, what's an API? And I'd argue that APIs are a contract. They're something that's agreed upon between client and server, saying, here's the information I want, here's when you'll get it to me by, here's everything that should happen as part of this exchange. And that means that your goal as an API designer is to create a shared understanding of how your API should be used. And like a real contract, this depends a lot on your audience. Taking a real world use case, from my experience at Segment, we've at this point switched through about 3 or 4 offices as we've grown. And each time, the number of pages in that lease agreement has grown basically exponentially based upon how much office space we need. In the first agreement, it was just 4 of us moving from an apartment to a live-work loft. That was only 2,000 square feet, so it was a very easy process. For the most recent agreement, we ended up having to get lawyers involved and spend countless hours signing this agreement and going over all of the red tape. And the reason for that is because now there's a lot more on the line, and as we've kind of evolved our stage as a company, there's a lot more corner cases that need to be covered as part of this API between us, the client, and the rental manager. And so the most important thing to know here is that just your API has to meet its audience on its terms. Unlike the rental market, it's very easy to change APIs at the drop of a hat. And so if you want to make your API compelling, you have to make sure that it's friendly for your clients. Now this can be tricky because there's a lot of words that we like to use to describe good APIs. Maybe they're powerful, flexible, composable, modular, all these different things that we really want. On the one hand, we might go for simplicity, like the Yo API. You can basically get or post Yos. Or maybe we want power, something where you can endlessly tweak all of these knobs and come up with hundreds of millions of different configurations and settings for your exact business. But it's not the sort of thing that you can explain in a couple of words or even a sentence. Maybe we want something that's widely adopted, where it appeals to the lowest common denominator. Just drop some HTML and JavaScript on a page. Or maybe we care about something where it's more cutting edge. We're using a new form of technology that our clients actually prefer and would love to work with. In short, there's trade-offs everywhere. And what's frustrating is that it's really hard to have them all, even though we might want them. It's really hard to find this sort of center place between both simple and powerful, flexible, but without being too complex. And so in this next section of the talk, I'd like to explore some ideas for how we mitigate those and compare those trade-offs. In particular, I'd like to highlight one technique that it seems like is gaining prevalence, which is to split your API by the audience using it. Now, the way we actually do this is by splitting our API into what I term as levels. In this case, you actually have a high-level and a low-level API for the same data model, acting on the same methods, but the abstracted APIs give your client kind of an easier way to deal with your API that maybe hides some of the complexity from them. As a quick example, I'm sure some of you are familiar with Kafka, this popular pub subsystem that's come out. Kafka is actually a distributed log where publishers can write messages to the log, consumers can read from them. You can think of it almost as a queue like RabbitMQ, NSQ, those sorts of systems, Redis. In particular today, I'd like to focus on the consumer aspect of Kafka. Now, actually in Kafka's documentation and spec, they keep 2 separate consumer APIs. One is the high-level API, which hides a lot of the state and transfer from clients. And the other is the low-level API, which you can use if you want to get at raw offsets or bytes. And the way this actually works in practice is that you might have a simple consumer here, which is honestly very hard to see. But the general idea here is that it exposes a few methods which all relate to dealing with bytes, dealing with raw offsets. If you require a different consistency model, you can achieve it. If you want to rewind where you're at in the log, you can achieve that. The high-level consumer, on the other hand, simply requires that you, as the developer, implement a few methods, and suddenly you're dealing with Java objects, you're dealing with streams, you're dealing with iterators, all of these nice things that hide a lot of the complexity for you, but maybe sacrifice either the performance or consistency model that you're looking for. As another example, we can take the S3 API. If you're using the AWS command line prompt, at a high level, there's this S3 command, right? You can run it. You can run ls, cp, move, rm, all of these operations that we're used to dealing with our file system. It'll spit back output that looks a lot like you were just running this on your local disk. But what they also expose as part of the same binary and same API is the secondary system called AWS S3 API that you can then use to get at the lower level implementation. You can actually find out values about these objects, what their storage class is, metadata associated with them that you don't get from the high level API. So we've looked at what APIs mean and how we might trade off between different aspects of the APIs. We've looked at how to mitigate them with levels. I wanted to wrap up this talk with a few new ideas that we're seeing in the wild. In particular, some interesting points of how APIs are evolving past sort of just the basic REST HTTP APIs that are fairly prevalent today. So the first idea is going what people are calling API first. Now, in the same way that some products are mobile first, API first products strive to make everything an API. There shouldn't be anything that's done through a UI or a CLI that can't be achieved the same way programmatically. And perhaps Kubernetes is the best example of this that's appearing on the market today. For those of you unfamiliar, Kubernetes is a container scheduler and orchestration tool. And what that means is, say you have a bunch of instances or a bunch of computers that you want to run a particular service on, Kubernetes will help figure out which computers should run which versions of your program. And while that in itself is cool, perhaps the coolest thing that's actually allowed Kubernetes to burgeon as a new ecosystem is the fact that it's built entirely API first. And it ships out of the box with this high-level API, which is a command line tool called kubectl. But under the hood, all it's doing is hitting these various REST methods. And so as an example from their documentation, say you want to get a version of the recent deployments, they actually include both the URL that you can hit as well as the kubectl command if you're just running this locally from your box. So you can run this gigantic curl if you're accessing programmatically and want to really dive under the hood, or you can just run kubectl get deployment and give my output as JSON. I'd argue that if you want to be an ecosystem, you have to be API first. If there's some functionality that you just can't achieve without accessing it programmatically, then you've basically handicapped a certain portion of your product so that it can't be used by outside developers. Second idea here that's starting to take off is this idea of generated clients. And the whole goal here is that you write some sort of code once, you write a spec, create it, and then you can reuse that spec anywhere, no matter which programming language you're using. And the great part about this is that it actually meets developers on their terms in their native language. You don't have developers anymore who are implementing this weird HTTP spec. There might be status codes or JSON bodies that aren't quite to spec. Instead, you have a client which basically has a set spec that's kind of the lowest common denominator among languages, and then people build on top of that. And perhaps the most widely, or the one that's gaining the most traction right now appears to be gRPC, Google's RPC library. For those of you unfamiliar, gRPC is Google's open source RPC framework. The general idea is that you define types once in this language called protobuf, and then you're able to generate clients in any language, Go, Python, JavaScript, etc. And instead of basically shoehorning us into this REST model where you have these objects and verbs and HTTP actions that can actually be hard to get right, as we saw in the last talk, this more defines your model in terms of functions that you can run, just straight up remote procedure calls. So as an example of how this works, here's a quick protobuf that we can say, hey, I have my service greeter, I can define methods on it, and I can define the inputs and outputs for that. And then by running this simple CLI script, I can actually generate code in Go, or I can generate the same client in Python, or I can generate the same client in JavaScript. Whatever it is that I'm using, I can basically base my client off this common implementation. And this is great because owning the client allows you to move the interface to the language level rather than this HTTP spec that you've defined. And there's a lot higher chance that your clients will actually, one, begin to use it, and two, use it correctly. So the advantages here, first, it just avoids implementation errors, which is especially important if your API is trying to serve many different clients. This is something that we messed up in the early days of Segment, where we had our API set, and then we built clients in Ruby, JavaScript, Python, Java, Node, .NET even, etc. And it turned out that there were a lot of inconsistencies between those different libraries based upon who had implemented them and at what time. Second is it allows you greater API control because you're able to really well define the spec. And then the third is that it allows your devs an easier path to get started, assuming that you have their language implemented. Now, you might be thinking out there, wait, generated clients, common data format, something seems familiar about this, maybe reminiscent of this technology that we all hate from the early 90s and late 80s called SOAP. And I'd say, yeah, SOAP and gRPC are actually fairly similar. SOAP is this protocol that relies on XML. It also has this idea of kind of a single endpoint and discoverable methods that you can actually call on each of these objects. And you end up generating clients in various languages based upon that XML spec. But what I'd argue is different here is that SOAP was actually fairly not tightly spec'd, let's say. And so it left a lot of room for people to create errors when building their implementations. As an example, I was just interacting with the Google AdWords API to pull data from AdWords accounts. It's written in SOAP. And I kept having my program crash, and I wasn't sure why. And it turned out because there was actually a Unicode escape character that was in the XML, and it was crashing the Python XML parser I was using. Now, this took me a few hours to find and wasted a bunch of time. And what I ended up doing is just stripping those characters in the response body. But you can imagine if this is just me running into this once, how many times this has been people across the world. And I think the moral of the story here is that if your API is too complicated or your spec is too complicated, your clients will not follow the spec. It's bound to happen. So if you can, generate clients, keep it simple, make sure that you control most of the areas of ambiguity. And the third I wanted to touch on briefly, that'll be covered more in a later talk, is this idea of kind of smart endpoints. So many of you are probably familiar with this new type of endpoint or new type of API that's coming out called GraphQL that's starting to gain a lot more popularity. The whole idea behind GraphQL is that it's an alternative to REST. A lot of the ideas that we just saw, where instead of having many different endpoints, where you have one endpoint for your users, one endpoint for your accounts objects, one endpoint for your products, if you're running a music app, one for playlists, one for songs, you basically just get one single endpoint that has all of the data that you need. And the contract that the endpoint follows and the client has, so that this doesn't become crazy slow or return these giant responses, is that as a client, you only ask for the data that you need. In particular, this has been really popular on both mobile and client-side apps because it eliminates a lot of these multiple requests that might happen. So say you load a JavaScript page, you end up realizing, okay, I'm going to grab the logged in user, and then I'm going to grab my list of friends, and then for each of those friends, I want to grab some information about their profiles, and then from there, I want to grab their friends of friends. Ends up creating a fairly slow, fairly heavy experience. And GraphQL eliminates all that. And so the way it does this is actually, in some ways, similar to gRPC, where you first define your model. And so you'll say, hey, I've got a project. It's got a name, tagline, contributors, which are these users, which are defined elsewhere. And then if you want a query for it, your query includes all of the fields that you want returned. So in our case here, we're just returning the project object, in particular, only the tagline field from that object. And what this does is the query language itself has sort of forced the user into building something that's performant, that works well, that only gives them back the information that they need, which is why it's starting to see a lot more adoption, particularly mobile and client-side apps. That said, GraphQL is definitely not a panacea. It's really good at solving the right problems, but you could imagine that, say you're building a public API, which you want to be used from particular servers. Maybe this GraphQL format looks a little bit different than you want, or maybe you want better performance monitoring. It's kind of hard to get that from a single endpoint versus what you get with REST. So in closing, a handful of thoughts. At the end of the day, there's kind of no API which feels just right. But there are better choices for what to use depending on what your audience is. And it's worth, as you're designing the API, to just be upfront with who your audience is. Maybe it's cutting-edge developers. Maybe it's enterprise folks who are working in Java. Maybe it's hackers who want to get up and running quickly. Or maybe it's large corporations who need all sorts of customization tweaks and security guarantees. Ultimately, there's no right answer, but it depends on what your API wants to do, and there are ways to mitigate it using different levels, different interfaces, different ways of interacting with the same data. However, I'd argue there are a few things that actually just never go out of style. The first is making it easy. Do this via docs, clients, example code, whatever you can do to make it easy for your client to, one, understand your API and how it should be used, and then two, actually get up and running with that API incredibly quickly, will go a long ways. The second is making it fast. A lot of these API formats, if they take a long time to respond or they end up not being performant, cause people to drop them from their apps really quickly. This actually happened to us with a logging tool a couple of years ago. We dropped in the SDK. We were like, OK, it's ready to go. Send our logs. And it just immediately pegged the CPU on our servers because it didn't batch or do things asynchronously. The last one is to keep it simple. Simplicity tends to override kind of most of these other principles and allows you to do more with less in the long run. And the caveat there is that you actually just layer in where necessary. If you need a higher level API or a lower level API, you give those to the clients, but the fundamental data model stays the same. And with that, I'd like to thank you. Though we can never achieve our Goldilocks API, we can hopefully get it to as close to just right as possible. Thank you.